Hello, my name is Shivani, and I am one of the new Wyzant tutors, and I am here to help you with your physics problem regarding electric force. So let's take a look at the question. Nadine is solving for the distance in centimeters between two charges. The two charges have a magnitude of 400 newtons between them. He also noted that they both have a charge of 39 microcoulombs. What should be his computed answer? So basically, we're solving for the distance between the charges given the force. Here I have written down the force, the electric force formula, which is K times Q1 times Q2 over R squared, and it is measured in newtons. So taking this formula, we can rearrange it to see if we could come up with an expression for R. R is the distance in meters between the charges. So let's go ahead and rearrange this formula right here. So F is equal to K Q1 Q2 over R squared. So we can rearrange it such that F times R squared is equal to K Q1 Q2. So then R squared is equal to K Q1 Q2 over F. So then R is the square root of K Q1 Q2 over F. So we can use this expression that we got for R to calculate the distance between the charges, since the question already gave us the magnitude of the force and the two charges, and we already have K, the constant. Now, it's very important to pay attention to units when you're solving such problems. So the force is measured in newtons. Q1 and Q2 have to be in coulombs. Notice that this question gives us the charges in microcoulombs, so we need to convert that to coulombs. So 39 microcoulombs times 1 coulomb over 10 to the 6 microcoulombs. So this is the conversion factor, since there are 10 to the 6 microcoulombs in a coulomb. So 39 divided by 10 to the 6 would be 3.9 times 10 to the negative 5 coulombs. And that would be the charges, the value of each of the two charges. The force between the charges is 400 newtons. So we can go ahead and calculate R. And I'm actually going to do this on a separate whiteboard. So R is equal to the square root of K. So that will be 9 times 10 to the 9 times 3.9 times 10 to the negative 5 times 3.9 times 10 to the negative 5 over 400. So now let's, I always like to make sure the units canceled out. So c squared cancels out with c times c. Newtons and Newton cancel out, so you're only left with square root of whatever number, meter squared. So let's plug this into our calculator. Square root, okay, so 9 times 10 to the 9 times 3.9 times 10 to the negative 5 times 3.9 times 10 to the negative 5 over 400. So it'll be the square root of 3.4225 times 10 to the negative 2 meters squared. And that would be 0.185 meters. All right, now so we got our answer. Let's take a look at the choices. So what would be his computed answer? So now we got that R is equal to 0.185 meters. Now the question is asking for the distance in centimeters between the two charges. So we need to convert this into centimeters. So there's 100 centimeters in 1 meter. So 0.185 meters times 10 to the 2, or 100 centimeters per 1 meter. And you get 18.5 centimeters is going to be our final answer. So that would be choice D in the question here. All right, so that sums up the answer and the explanations. And just some key points. First of all, to pay attention to units when you're answering questions like this, because although our calculated answer at first was 0.185 meters, and that is one of the answer choices, but remember that it's asking for centimeters, so we have to convert it for the instructions. And yeah. If you have any questions regarding my work, feel free to leave a comment in the comment section. Thank you and have a lovely day.